Great. Good afternoon, everyone. Welcome to the session. We're going to be discussing Hadoop in the cloud, the what, why, and how from the experts now. Of course, the title is recommended keeping Microsoft in mind. Don't think of me as being the personification of the expert portfolio all up, right? We've got a bunch of Microsoft folks over here as well, so we can ask them questions if I can't answer. But before we get started at all, have you guys been having a good Hadoop summit so far? Well, it doesn't seem like. You can be louder. Have you guys really been having a good Hadoop summit? Yes. That's more like it. Thank you so much. And I know this takes a lot to come right after lunch on the final day of the summit, so really appreciate your time over here. And I'm really grateful to all of you. Now, just to tell you a little bit about myself, I'm Nishant Thakur. I'm a technical product manager with Microsoft working on the big data stack. I work majorly on the Azure services that deal with big data, so where's the HDInsight service and the Azure Data Lake set of services, right? Now that said, although I'll keep on referencing some of the Azure components throughout the stack, but this talk is kind of agnostic of whichever cloud that you are more prone towards. Of course, I'll share my insights from the Microsoft Azure public cloud. Some of them apply to the other clouds with some limitations at times, and some of them do not. So feel free to kind of poke in questions as you have any. And I'll try to keep about 5 minutes towards the end for Q&A, and just in case you have any doubts or concerns. Now, those are my credentials. That's my Twitter handle. Let me know how I did, how I didn't. I'd be more than happy to improve my presentation as well as we get along. Now, let's go ahead and quickly look at the agenda that we have. My agenda is pretty simple. The title said the what, why, and how. We're going to go discuss the what, why, and how, but potentially not in the same order. The first thing that I want you guys to go back with is why does running Hadoop in the cloud make much more sense today, right? Now, all this while we've heard enterprises being very cautious about the cloud and probably not even looking at it, setting up their own infrastructure on premises, and like suddenly over the last 12 to 18 months, we've seen that influx growing. Even very, very cautious verticals like the financial services and healthcare are now trying to leverage the cloud and determine how it can help them grow in the future, right? The second piece and the most important piece is the what piece. So we'll discuss as to like what are the various options that are available. What are the kind of changes that happen as a result of you deploying clusters to the cloud, etc. And then what are the intricacies that you should care about while setting up your big data environment on a cloud. And then we'll just kind of skim through the surface of some of the deeper architectures around it, where I can give you a glimpse around, okay, where does this actually sit? And again, it'll tie back to the why piece as well as to why is it important that some of these pieces sit in the cloud and not on-prem, all right? So with that said, let's just dive into the first point of the agenda therein. Now, let's go ahead and take a look at what traditional Hadoop clusters look like today, okay? So any traditional Hadoop cluster would have potentially three major components: a storage environment. For Hadoop, it's HDFS. A compute environment. For Hadoop, it could be the yarn layer. And then a programming paradigm. For Hadoop, that's MapReduce, which is essentially the distributed programming paradigm. But in essence, what they ideally have is a bunch of machines. Those machines have the compute resources and the storage locators. And then you install some bits on top of those machines to go ahead and distribute the processing across all of the compute and the storage power that those machines have, which is fine, perfect. It works exactly the way you want it to. You can deploy exactly the bits that you want on them, and you can play around with the latest and the greatest and the cutting edge technology of the open source world as well. Now, a caveat there. What happens when you want to go ahead and have potentially some flexible requirements? Are you going to keep setting up these clusters again and again for all of your environments? Potentially no. A more important caveat, what happens when you need more resources, when you need more compute power, when you need more storage? Well, of course, somebody can stand up and say, what are you talking about? You can go add more nodes to your cluster. You can keep on adding more nodes to your cluster and grow the Hadoop cluster or the Spark cluster, whatever you're working with, and that's perfectly fine. But now, just imagine if that was just an experimentation project that you were doing, or if that was a seasonal workload that you were playing around with, which is more often than not the case. You always have a core set of workload, and then you have a lot of surrounding workloads that are pretty much either exploratory or very seasonal, given the vertical that you're creating those clusters out of. Now, for example, let's take up the retail vertical. You go ahead and set up a cluster, a 4-node cluster, which works perfectly fine for user profile and giving you the user 360-degree view of it for a small set of customers that you have as a retail organization. Now, come Thanksgiving, come Christmas, you need much more compute capacity on them, and you grow your cluster. But what happens on the 1st of December, or potentially the 10th of January, when that seasonality has actually gone down? Can you go ahead and actually get rid of these clusters as a whole, or the nodes within the cluster? Is there like an eBay or Amazon where you can sell those nodes? And then, more importantly, are you ever going to be reusing those nodes? Given the world, the compute resources and the hardware and the processing power is moving ahead with, 1 year down the line, the resources in a particular node could be completely outdated from what they were a year back, right? So you cannot even go ahead and keep them, let's say, as a kind of potential backup or for the new seasonality that comes across, because you've got new hardware to deal with. And then in this changing paradigm, you sometimes need a different vector of hardwares altogether. All this while we were dealing with Hadoop over the last about 8 years or so, and suddenly over the last 2 years, people start looking for more memory-intensive commodity hardware. Although I always challenge the definition of it, like how can you get memory-intensive commodity hardware? So it's no longer the world of commodity hardwares as such. And the way it's moving forward, you really need to take into account the kind of changes that are going to happen in the hardware space, as well as what we as contributors and committers are writing in the code base of the open source ecosystem to leverage the resources. And as such, to be wasting all of these resources in terms of money, in terms of manpower to first set it up, and then spin it down with no usage of those nodes whatsoever, is kind of disastrous. In the first place, to even get to the stage of a large cluster, you would potentially spend about months trying to get approvals, and then another set of months trying to set up this cluster and add more nodes to it. So even that time and effort is important for you. Now let's go ahead and take a simplistic view of what are the challenges with these traditional Hadoop clusters. So essentially, we talked about this in the previous slide. There are 3 parallels. One is upfront hardware costs. Even to set up a 4-node Hadoop cluster, you need thousands of dollars, right? Which needs approvals, which needs kind of visibility right up your value chain up to potentially the executive leadership. The second most important piece is capacity planning. Like, how do you do that? I mean, today you have some demand, tomorrow you're getting more data, third day you have seasonal exploratory analytics to perform on top of it. The fourth day there is a new open source tool that's coming in which uses a particular resource on a node more than anything else. And how can you even plan for it in advance, right? And the third, of course, the people in this room. You see that? They are so scarce. The whole community is such a prized community and a possession that all of us in the platform world have, that you guys are very scarce for customers. We need to grow this community, but at this point in time, it's pretty expensive. All of you, I'm sure, charge a hefty premium to be working on these technologies because this is the cutting edge of the technology, okay? Now, let's go ahead and take a slightly different view of this now. All this while we've been talking about traditional clusters. Let's go ahead and take a look at clusters in the cloud now. What happens with clusters in the cloud? Well, pretty much the same thing. You got a set of compute resources, you got a set of storage resources, you install the bits on top of them, and you keep growing as you would in a traditional sense. So you just go ahead and keep adding more nodes, because in the cloud, you can just go ahead and hire more nodes and put them in your Hadoop cluster. And the moment you decide you don't need those nodes, well, go ahead, get rid of them. Who cares? It's going to be one of these cloud providers who's going to worry about what to do with those resources that they had provisioned for our cluster, which we don't need now, and we are not ready to pay for it anymore, right? So that's one of the things that really, really attracts a lot of enterprises today. I want a cluster, but I want it for 4 hours in the day to process my big data. I don't want it to be running 24/7, 365 days in a year. I would potentially have it running, say, about, I don't know, 10 days in a month, if at all it's a huge and humongous workload that I want. And if at all I have a streaming workload, I would keep a very small subset of that cluster running to go ahead and do the processing on the streams as they come in, depending on the workload that we are processing over here, right? Now that's the essence of Hadoop in the cloud. The first thing that you can take advantage of over here is there is no upfront hardware cost. All you need is a credit card and enough credit on it such that you can tie it back to a subscription and pay as you go with all the resources that you use. The second is, well, have you ever tried deploying a cluster which is upwards of 40 nodes? All right, let's actually take a poll over here. How many of us are working with Hadoop in production today? Pretty good. How many of this subset is actually working with upwards of 40 node clusters? About 15%. How many of these people are actually working with Hadoop clusters in the cloud? See that? A very small set of people. And that is because you're not even working upwards of a kind of a threshold in terms of the processing capacity for big data workloads. Now just imagine you having the scale to process all of your data across 2,000 nodes and bringing down your processing time from 6 hours to potentially 5 minutes. And all that you're paying for is those 2,000 nodes for 5 minutes. Once your processing is done, you're spinning your clusters down and you're losing away all of that hardware that you were paying for, right? The second, or probably the last one is, if you've ever set up a Hadoop cluster on a bare metal box, it takes weeks, if not days, to go ahead and set up that cluster as a whole. 7 years back, when I set up my first kind of 6-node Hadoop cluster back in my organization, and it was kind of a side project for me, it took me about 4 months to do it. Of course, the code was very buggy. To even get the network connectivity going within the Hadoop bits was like a nightmare. It took us 2.5 months of baselining the code and plugging and kind of patching all the loopholes over there to get it working. Today, if I have to get a 1,200 node cluster, I go ahead and do a set of 3 clicks at max. I go grab a coffee, and before I'm back, my cluster is up and running for me to start working on. That's the power of the cloud. Because the cloud actually has resources already available and is waiting for people to ask for those resources. Like, come, take it from me. I cannot save it for anybody else. You are our customers. And that's the way the cloud works. That's anywhere, be it Amazon, be it Google, or be it Microsoft's Azure cloud, right? So you can go ahead and ask on demand. You can go ahead and set up resources to the tune of your workload, and it'll all get deployed in a span of minutes, potentially, if not even seconds, okay? Now, let's go ahead and take a little deeper look into the kind of functioning, or rather the attributes of these Hadoop clusters. The first major component for a Hadoop cluster is definitely the distributed storage. Of course, we refer to it in different forms. Some people call it HDFS because it's the Hadoop's distributed file system. Some people call it something else. Some companies even have proprietary formats for it, etc. So the essence is you get files, you want to go ahead and split them into smaller pieces, you want to shard them across to multiple locations so that when the processing comes, you can utilize the processing power of the individual pieces over there. Okay. Now, the second piece is, of course, you got the data, you shard it across. Now you need sharded across compute resources. So that's distributed compute resources in there, right? And it essentially ties back to potentially the MapReduce programming paradigm over there. The third one is the automatic failover. So resiliency, high availability, that's important, right? Using commodity hardwares, you've been able to achieve this all this while by keeping 3 copies of the same data across multiple nodes on a Hadoop cluster, and then you've been able to fail over whenever there is like a commodity server failing around it. The next piece is the scale. Like you can just keep on adding more nodes wherever you need it. And this I'm talking from a traditional Hadoop cluster standpoint as well. Like you can have a 4-node cluster and you can go ahead and request for, I don't know, 400 more nodes and spend time going ahead and adding those 400 nodes to your cluster as you deem necessary. And then it's extensible. So this whole community is a result of this particular attribute of the Hadoop clusters. You can go ahead and write more tools, more services on top of it because everything embedded inside of a Hadoop cluster is actually exposed with the help of REST APIs and kind of extensibility features for SDKs, etc. Okay? Now that's a Hadoop cluster. Now what if I told you that I was just going to go ahead and change the title of the slide to be cloud? Does this still hold good? Would anybody challenge this slide and what is mentioned over here? I thought so. Now bring it together with Hadoop in the cloud, and you're actually exponentially improving the quality of whatever you're doing and the attributes thereof. So essentially, you're trying to bring Hadoop's distribution on top of the cloud's distribution, which is going to go ahead and add it to the power of 2. Same with the programming paradigm, same with the cluster architecture, same with failover mechanisms, extensibility, etc., all of it. And that is why we feel that Hadoop and the cloud, or rather big data and the cloud, are actually a match made in heaven. Like this was a workload that actually needed people to set up their own clouds in their own environments. But now, do you really want to be in the business of maintaining a data center, or do you want to run your business in your vertical that you're specializing in and leave the data center maintenance to the cloud providers themselves, right? And that's the essence. So I hope by now I've been able to convince that, okay, yes, potentially this is the way to go. Now let's go ahead and look at some of the attributes of what is available in the cloud today and why does it make so much more sense. So there are primarily 3 options for Hadoop in the cloud. The first one being Hadoop and IaaS, which essentially means that, okay, you got your Hadoop bits, you've subscribed to, I don't know, whichever distributor, or you subscribe directly to the Apache trunk, and you've downloaded those bits, but now you needed resources to deploy it, so you've gone ahead and hired some compute resources from any of the cloud providers, and you've deployed those bits on top of it, which essentially is that you've hired infrastructure from these cloud providers like VMs, and you've deployed those bits on top of those VMs and made them work together. Again, lots of pros and cons to it as well. So of course, this is your cluster, you have full control over it, the way you want to deploy it, which bits you want to deploy, which version you want to deploy, which flavor you want to deploy, all of that's in your hands. So you can go ahead and take complete control of it. Even if you want to deploy some custom tools that you've created and you do not want to give anybody else those tools, you can go ahead and deploy those tools on top of it. Okay? Potential risks or caveats to that is, what you're doing in the cloud is just taking the infrastructure over there, which means you're only taking advantage of maintaining the underlying infrastructure with the virtual machines that these clusters are deployed on. The second, you still need all the manpower to administer these clusters and maintain them in a running state. And potentially the third, since these clusters are set up on VMs and you're using the whole package of the VM to be your distributed architecture, these clusters need to be running all the time, 24/7, 365 days a year. Because otherwise, if you spin them down or you scale them down, you're going to lose the storage that was on the other VMs, right? Because you're even using the storage in those VMs. Now, the second option for Hadoop in the cloud is actually in platform as a service, which is essentially also called managed clusters service. Now, all the public clouds have an offering in this space. This is more like you go to a portal, you say you need 100 nodes, you click a few buttons, you go grab a coffee, come back, and your cluster's up and running, and you can start working on it. You don't need to worry about keeping the cluster up and running. You don't need to worry about the bits being buggy or there being issues inside of the cluster. All of that is taken care of by the provider, given the SLA that they commit towards, right? For example, Microsoft Azure commits to a 99.9% uptime on its managed Hadoop cluster service called HDInsight. So in essence, which means you don't need to worry about it. If something goes wrong, I get a call at 3 in the morning that something's not working, and I got to wake up and make sure that the right resources are put into place and things are working over there. Now again, pros and cons to that too. The pros, it's SLA bound, so you have peace of mind. Again, you got flexible resizing. You don't need to worry about increasing the number of nodes and the seasonality, decreasing the number of nodes during slower times. You can even go ahead and automate that to determine by certain criteria, etc., right? And then you even got customization options. So in case you want to deploy something that's cutting edge in the open source world, you can actually go ahead and take that. For example, I don't think any of these managed cluster services today offer tools like potentially Beam or Flink for that matter. You want that? Go ahead and download it from the Apache trunk, push it as a customization option on your cluster, and you're good to go. So you got all of those customization options in there. But then there is a con to it as well. Like, you got to forego some control. You do not have control to the logs of your data nodes inside of your cluster if you want to start going ahead and debugging some of those aspects around it. But then again, you take some, you leave some, right? Now the third option for Hadoop in the cloud is actually big data as a service. Again, a very, very fast growing paradigm today. All of the major clouds have some service or the other in this particular area. In essence, what this corresponds to is, stop worrying about clusters at all. Like, is that really your job? Is maintaining a data center your kind of work? Leave that to the cloud providers. You just bring in your data and bring in your queries and start firing them across your data. You pay as you go in terms of the number of queries you fire, the amount of processing power that those queries take, which is also controlled by you, and you only pay for the amount of time that that query runs, which essentially means I am just paying for the resources when I'm using them, and I'm not paying for even a cent more than that, okay? Now again, a few pros and cons over there. You completely abstracted from the cluster maintenance and management principles altogether. Everything is automated, so you don't need to worry about it. It's happening in the back end. All that you need is a slider which says, well, okay, this particular query looks pretty big. I might as well go ahead and give it, I don't know, 400 units of parallelism. which essentially means that we got to take care of splitting that query into 400 units of work and trying to find resources for those individual units of work to execute in parallel. And all of that is the responsibility of the cloud and not yours. All that you need to do is write your query. That's it. Now again, as with the others, there are certain caveats. So you kind of completely forego any control. You can't even see a cluster. You can't even see the infrastructure. All that you see is, okay, there is an error. It gives you a description of an error if there is ever one. And you just need to go ahead and correct your code because, of course, these are robust systems. Potentially, there is nothing going wrong with the provisioning and the resources that are working in the back end. And there is something that's potentially mimicking some unexpected behavior in your query itself, right? And the second piece is, of course, not everything is available over there. So although that ecosystem is growing, there are few customers in that space right now. A lot of them just exploring it because it's so new. They're just getting their feet wet. And as that ecosystem grows, I'm sure you're going to get many more tools around that space. So essentially, what you're looking at are the three kind of Hadoop deployment options that you have in IaaS, in PaaS, or as a service, right? Now, let's go ahead and see why would you even use cloud, or for that matter, is there an option for us to even run it as a hybrid workload with on-prem as well as cloud deployments? Well, actually there is. There are three scenarios when you would ideally want to run it as a hybrid workload. You've already got some on-prem Hadoop clusters in place. You're playing around with it today. But now you suddenly have a seasonal requirement or a very specialized workload. Like, let's say you want to go ahead and simulate Monte Carlo executions, right? Now, to be able to do that on an on-prem cluster, you'd have to add so many nodes to it. Do you really want to do it? You can actually burst to the cloud, say, okay, this is a specialized workload that I run only in the cloud. If you're in a very regulated industry, you can execute all of your non-PII or non-critical workloads in the cloud as well, given your regulatory constraints. The other is bursting to the cloud. Well, you got seasonality. Today is Thanksgiving. I don't know. I need 400 node cluster just for the next 6 hours, but I just got a 10 node cluster on-prem. Let's go ahead and get a 390 node cluster up on the cloud and try to merge both of these to execute in a burst mode fashion. And all of that's possible with hybrid deployments today, with tools like Falcon and tools like Azure Data Factory, which are seamlessly talking to each other for data movement as well as execution command movements across on-prem and cloud clusters. This is becoming more and more a seamless thing for customers. And then, of course, you're growing. Over the last 4 years, if you've not seen, we've literally tripled the amount of data that was generated over the last 50 years before that. And it is anticipated that by 2020, we're actually going to have 10 times the amount of data that we have today, which means in a span of years, we are growing with data exponentially away, right? Now, that's more from a deployment perspective. Now, this is potentially a very high-level view of a traditional Hadoop cluster which resides on-prem. So you have a master node which has kind of task trackers, which is like your head node over there. And then you got a bunch of data nodes which have kind of storage environments over there and compute resources on top of them, which are performing certain tasks. Okay? Essentially, in the cloud, these kind of clusters actually have a different architecture overall. In the cloud, the clusters, at least in the PaaS and the big data as a service world, exist by decoupling your compute and storage separately. Now, I can already see a few eyebrows raising over here. Well, wasn't the whole paradigm of Hadoop to bring compute to the data? And you're telling me that you're separating it in the cloud? Have you gone crazy? Who put this guy up on the stage? Well, actually, no. That was the paradigm 10 years back. when Hadoop was conceived. Today, with the advancements of network technology as well as storage capacity, you can actually keep them separate and still have them behave the same way as if they are residing on the same environment itself. Essentially, there is actually a network which engulfs both of those resources together, and you're sitting and capitalizing on resources that are coming in from one to the other. Now, let's go ahead and take a deeper look at what such an environment would allow us to do. And one such environment is, of course, HDInsight, which is an Azure service. So again, it's a fully managed Hadoop and Spark service in the cloud. It's completely open source. It's based out of the Hortonworks data platform as well. And then you can get clusters up and running in minutes over here. But more importantly, what's significant is that the total cost of ownership is actually 63% lower than if you were owning any on-prem cluster today. And this is not Microsoft saying it. This is actually a research paper from IDC saying it, and we've quoted that back down there as well. Right? Now, that's one of the things. Let's go ahead and take a look at a cluster architecture for HDInsight clusters. For HDInsight, it essentially boils down to how do you maintain some of the SLA requirements that you commit towards. For example, high availability. Can you ever forego a head node going down? Well, I cannot see that happening ever. And that's the reason why we actually have highly available architecture for head nodes as well. Of course, the worker nodes, there are multiple ones of them, and there is the same paradigm of 3 copies of your processing going to each one of them, and you're prioritizing where it needs to be executed, etc. And if any one of these goes down, you can always rely back on another one of those nodes to take up the execution from the state it failed. But the more important piece is, look at the storage layer. The storage layer is sitting outside of your compute layer, which in essence means that even though there are compute VMs deployed as part of your worker nodes, you're not actually utilizing the storage capacity of those VMs to add up to your HDFS layer. Your HDFS layer is actually sitting on top of an object store like Azure Data Lake Store or Azure Blob Storage, which provide you with immense throughput and hyperscale capabilities to go ahead and support all of your analytical workloads. Now, mind you, when you go with commodity hardware or on-prem clusters, those hard drives are not designed for such random reads and writes as they are happening through it and processing of analytical workloads. It is bound to reach its max capacity the moment you get to any sizable limit. Okay? But with something like the Azure Data Lake Store, all of those limits are gone away. If you've got 1 petabyte size file, go ahead and bring it and store it in its native form in 1 petabyte file size inside of the Data Lake Store, and allow the Data Lake Store to determine how to process that all by itself using complex algorithms coming out of Microsoft research and tested and burnt using internal systems like Bing and Office 365 and Xbox, right? Now, that's one of the pieces over there. Let's go ahead and discuss a little further into what are the implications of distributing or decoupling compute from storage. I'm sure all of you have questions around these 3 aspects, like, okay, what's the bandwidth like? What's the latency like? Does it even have any consistency? You're telling me take this away. What do I have to do around that? Well, let's be at peace with the fact that all of this is at a scale which can take care of any questions that you may have around the performance of the clusters. Now, I'd be the first one to put up my hand and say, okay, this is not exactly 100% as compared to having it sit on the same environment, but it is potentially 99.8% the same. Now, that 0.2% trade-off, we'll discuss what you get as a result of that. But just to give you some numbers as they come across, the latency is almost like on hard disk. You've got network bandwidth of 50 terabytes plus as part of the Azure flat network structures. you got very strong consistencies because these storage environments are available for you to provision with local redundance, data center redundance, geolocation redundance, as well as across geolocation redundance as well. So you can actually go ahead and provision your storage environment in the US and say, okay, I've got an office in Europe. I also want a copy of the data over there and want to spin up a Hadoop cluster in the local data center. And you are more than welcome to do that. In addition to that, there are checks in place where you can even go ahead and spin down your cluster in one space and spin it up on another and still see very consistent amount of data coming through. Okay. Now let's go ahead and take a quick look at what are the kind of benefits of decoupling this. And I'm going to split it across 3 pillars again. The first one being query pillars. So these are all query clusters that you spin up, normal Hadoop, Hive, and Pig, and potentially even now Spark, right? Now, Spark has just gone GA on the HDInsight clusters as well. So just look at the kind of benefits that you get out of it. Imagine you having the cluster and utilizing the storage capacity of the individual nodes. For you to be able to query on that, you would always have to have the cluster running and deployed. But if you decouple them, you can only spin up the clusters when you're processing the data. You can spin them down once the processing completes, but the data still exists, and the resultant of this processing is also stored in a persistent format inside of your storage environment. So all of your tools, all of your processes, all of your applications can still connect to the data that is there without you having to pay for any compute nodes in the cluster whatsoever. Let's take a look at some of the NoSQL workloads, and for us, potentially the best example over there is HBase. Okay? Now, HBase, traditionally, it is not a very compute intensive workload. It is a very simple query that's written to potentially a key value store to fetch data and do scans across it, which is not at all compute intensive. But if you need more data to be stored inside of a HBase cluster, you keep on adding more nodes to your cluster just because you want the storage capacity of those nodes to be added up to HDFS. Now just imagine if you decouple that. Your storage is decoupled from your compute. You can keep a small little 4-node cluster running to process petabytes of data residing in your storage environment, and that is a scenario that our customers are today testing out. To just give you a glimpse of the scale, Facebook-like clusters, which are 1200 node plus clusters on HBase to process just the Facebook Messenger, could perform at the same level with a 100-node Hadoop as a service or big data as a service cluster inside of HDInsight, with Azure Data Lake Store giving it the right throughput coming off it. Also, let's go ahead and take a look at some of the streaming workloads. You just need to run the clusters while the streams are coming in. If you know your streams are going to come in for a particular day or particular hours in a day or particular days in a week or particular months in a year, that's the only time your clusters are running. Your streams have gone in, they've been processed, there is data that resides inside of the persistent storage, and you got all of that coming through. I hope that gives you a glimpse of what that looks like around it. Again, just a quick look at the Data Lake Store. In essence, it is a very, very high throughput, no limit store for very, very low latency reads for analytical workloads. It is designed keeping in mind the big data ecosystem. It is being used today by internal systems as well as by some of the key customers to get very high output from this environment. Now let's go ahead and take a look at, okay, you talked about clusters. What kind of customization options do I have on them? Well, ideally, you can customize whatever you like, and to persist even the metadata that you create outside of your Hadoop clusters, you can go ahead and persist them in meta stores which are connected from your clusters themselves. But if you want to bring in more tools, there are provisions like script actions that you can run on it to go ahead and bring in all of your cluster information. And again, the integration options from all of these server capabilities also come in. For Spark, we've now even added Livy Server as one of the integration options. Now, the only last topic that remains is the how piece. What do cloud deployments and big data look like, and why does it make sense for us to do it in the cloud only? But it's not only about Hadoop. It's also about some of the surrounding services that you have on them. And all of those services could be in the cloud as they reside. So you can go ahead and consume all of those services as well as take advantage of all of them, be it in the batch mode or the streaming mode. And just to give you a glimpse of how does it sit as part of the Cortana intelligence, you got all of these services that surround your cloud deployments, and you can take advantage of Hadoop to sit with all of them together. Again, this is actually kind of the way the data would flow across all of these services as well. That pretty much brings us to an end of this particular talk. I'll leave this kind of couple of links for you to take down if you want to go ahead and play around with these services, and potentially my contact information if you have any questions. Sorry I couldn't save any time for Q&A, but I'll be around if you need any answers to it. In addition to that, I've got a few Azure passes in case somebody wants to try them out today. So come up to me and I can give you those. And the architecture that you saw on that slide, I've got a big poster of that as well. So for the first few who come up, we can share that with them. Thank you so much for standing by, and thank you for listening too.